All right, so today we're doing the Chapter 6 review. Question number 1 says to consider the polynomial 6x squared minus x to the third plus 4 minus 5x. So the polynomial has 4 terms. A says to write the polynomial in standard form. So remember, to write it in standard form, you need to write it in such a way so that the exponents are going down in order. So I'm going to pick the term that has the highest exponent, and then I'll pick the term that has the next highest exponent. Notice that the negative stayed with the x to the third, and then the 6x squared, that was that first term, it was positive, so it stayed positive. Then minus 5x, and then plus 4. So I have the same number of terms as when I started. I'm not going down in order by the value of the coefficients. I'm going down in order by the value of the exponents. B says to identify what is the degree. And so recall that the degree of a polynomial is whatever is the value of the highest exponent. So in this case, it'll be first. If I was looking up at the original polynomial, I'd have to find the x value that had the highest exponent. And so for this one, the degree of this polynomial is 3, since 3 is the highest exponent. And then part C says to identify the leading coefficient. And so again, if I look here in order, the leading coefficient will be whatever the coefficient is on the first term. If I was looking at the original one to answer a leading coefficient question, I would have to figure out which one had the highest exponent and then look at the number directly in front of that one. But either way on this question, it's -1. All right, on question number 2, it says of the list, I need to go through and identify which ones are monomials. So again, from the list that's on your paper, you want to recall the definition of monomial. And so here I'll write the list. So -5x to the third, 9x to the -2nd, -a to the third, b to the second, x minus 2, 2 over x to the fifth, and then 6 with the square root of x. So out of this list of 3, only 2 of these are identified as monomials. So we're going to remember the definition of monomial is that it's a single term. So it'll be coefficients. They could be positive, they could be negative, connected to x values or other variables, but they all have to be connected by multiplication. And then there's a couple of rules. So you're not allowed to have exponents. You're not allowed to have variables be in the denominator of a fraction. So since that's the case, there's 2 that you can cross off initially. So 2 over x to the fifth, that one's not a monomial because that one has the x to the fifth in the bottom. And then if you look up here, remember negative exponents would just flip variables into the bottom of the fraction. So anytime you see a negative exponent, that also means it's not a monomial. So there's no negative exponents. And then for this one, it was no variables in the bottom. There's a couple more that we can cross off that are not considered monomials. One of them is this one right here. So x minus 2 has 2 terms. Terms are separated by addition or subtraction. And so in this case, we can also cross off this one because this one's a binomial. And then the last one that we can cross off is the final one in the list. So you can't have any variables that are underneath square roots, and you can't also have any exponents that are fractions because those are the same thing. So 6 with the square root of x, no variables underneath a radical. So out of this list, it's the 2 that we haven't crossed off yet. So this one would be a monomial, and this one would be a monomial. Question number 3 asks us to add the polynomials. And so let's see, x to the second plus 2x plus 3. Notice the very important plus sign that's in between these 2 parentheses. Many students, when they're doing this question, start foiling because you see the parentheses and you think that parentheses means multiplication, but be careful. These are in parentheses to signify that this is one polynomial. These are in a second set of parentheses to signify that this is its own polynomial, but it does have a plus sign in the middle, so all I'm doing is combining like terms. These two will go together, and then these two will go together, and that's the best that I can do. So my answer for this one, when I add by combining like terms, is going to be 2x squared, because x squared plus x squared would give me 2x squared. The 2x doesn't have 1 to combine with, so that one's going to stay 2x. And then 3 take away 5 would give me negative 2. So that would be my answer to that question. That's the most that it can be simplified. You can't continue adding these together because they're not like terms. Question number 4 asks me to subtract. And so, excuse me, again, on A and on 3 and on 4, the word being there telling you what operation it is that you're doing can also act as a hint that you're not multiplying. But you just want to be careful. So again, looking in between these two parentheses, this would be a long problem if it was a true multiplication question, because you'd have to distribute this one, and this one. But notice that on this problem, you just have that negative sign that's in the middle. And so I'm going to subtract these two polynomials from one another. When I subtract, subtraction is the same. Subtraction is the same as adding the opposite. So I can take my negative sign that's here in the middle, and I can distribute my negative sign to the second set of parentheses. And so when you distribute a negative, multiplying everything by a negative causes their signs to change. So this 2 will be negative. This negative 5x will turn positive, and then the 1 will turn negative. Some students find that writing this out underneath helps them before they combine like terms, but that's up to you to decide if that helps you. When I combine like terms, these two go together, these two go together, and then I'll use a different symbol. Those two go together. So you're just going to match up the ones that match. 4x squared take away 2x squared is going to give me 2x squared. Positive 1x plus 5x is going to give me positive 6x. And then last but not least, negative 3 take away 1 is going to give me negative 4. And so that would be the answer for that question. Question number 5 is also a subtraction question. Yeah, I can fit it here. And so on question number 5, I'm going to subtract. And here's what this one says. So there's two subtraction problems. 2x to the third plus 7x minus 4 minus negative 5x to the third plus 7x squared minus 3x plus 1. Just make sure that I have that written down right. So when you're doing this one, same thing. It's not a multiplication question, even though you see parentheses on it, because it has this minus sign in the middle. So since it's a subtraction question, I have to distribute the negative to each one more of the signs. Just the ones in the second set of parentheses, though. These signs don't change. So subtraction is the same as adding the opposite. And so this will change to positive, this will change to negative, this will change to positive, and this will change to negative. And then technically what you're doing in a subtraction question is after you distribute that negative, it changes this to an addition sign. So we should technically go back and add that in. Again, after it's been distributed, the negative has been put over here, so it changes this to an addition problem. So this one can go with this one. This one can go with this one. And then the constants will also combine together. So 2x to the third plus 5x to the third gives me 7x to the third. The negative 7x squared doesn't have 1 to combine with, but be careful that you keep that negative with you. 7x plus 3x gives me 10x. And then negative 4 take away 1 gives me negative 5. And so this would be my answer for that final question, or for that final subtraction question. All right, for question number 6, the directions for this one say to multiply. Actually, the directions for the next 5 questions say multiply, so I'm going to go on ahead and not write it on every one. So for this one, you know it's a multiplication question because you've got something out in front of the parentheses, so 2x squared, and then you have something on the inside of the parentheses, negative 5xy to the 6th. And notice that on this one, there's nothing in between this number, or whatever it is out front, the term that's out front, and the parentheses. So that's how I know I'm not minusing these two things together, even though there's a minus sign right here. because this one and this one are connected with parentheses, so that means multiplication. You might also look at it and think that you couldn't add or subtract these together because they're not like terms. So multiplication would be the only operation that you could do. This is a monomial, one term, and then this is a monomial, one term. So when I multiply monomials, the rule says I multiply the numbers that are out front. So 2 times -5 is going to give me -10. And then just remember the rule says that when you multiply exponents that have the same base, you add the exponents. So x to the second, and then this is x to the first power, even though there's not a 1 exponent indicated. So that's going to give me x to the third, and then y to the sixth. So that would be the answer for that one. Question number 7, the directions also say multiply. So this one says 2 minus 4x times 1 minus 5x. So just a point about how 7 is different than 6. 6 was a monomial times a monomial. 7 is a binomial times a binomial. And so for this one, I can use the box method for multiplication, if you've learned that before, or I can just go through and FOIL. And so I'll do my first outside, inside last when I go through and do my multiplication on this one, and then I'll finish by combining like terms. 2 times 1 is 2. 2 times -5x is -10x. -4 times x times 1 is -4x. And then -4x times -5x is positive 20x squared. So that's the initial step when you go through and do the multiplication out to get the terms that are in the answer to your question. So there's 2 things I'm going to change before I write my answer for this question. The first one is these 2 terms can combine with each other because they're like terms, so I can simplify those. And then the other thing is usually I write my answer in standard form. And so for this one, the answer that you see when you look it up on the back of your review, this one goes first. The -14x that you get when you combine these 2 together goes second, and this one goes last. So the final answer for this one is 20x to the second minus 14x plus 2. Question number 8 is also a multiplication question. This one says x plus 1 times x squared plus x minus 1. So for the format of this answer, I knew it was going to be a multiplication question because the directions said multiply, but I also knew that it was going to be a multiplication question because I have a binomial, x plus 1, and then the parentheses close, and then new parentheses start. And so in between the 2 parentheses, there's no space. They're right adjacent to each other. They're right next to each other. So that's how you know that this is going to be a multiply question. So again, you could use the box method if that's something that you've used before. Otherwise, I'm going to use the double distributive property, or sometimes we call this FOIL, even though it's not FOIL. So I'm going to do x times x to the second. So that's x to the third. Remember, this x does have a 1 exponent on it, so those will have to add together. X times x is x squared, and then x times -1 is -x. And so now that I'm done multiplying this one through, I'm going to go ahead and multiply the 1 through. And so I multiply together the 1 with each of these things. And then my last step is I just need to combine my like terms. So the x squared will combine with the x squared. And then the -x and the positive x will combine with each other. They're actually opposites, and so they're going to cancel each other out. So my final answer for question number 8 is going to be x to the third. X squared plus x squared gives me 2x squared. And then the -1 is just all by itself. So it finishes with a -1. This problem, instead of having 4 pieces to the answer, it only had 3 pieces to the answer because this term and this term happened to be opposites, and so they just happened to cancel out with each other. Question number 9 asks me to multiply this one. This is a really common mistake that students make when they're either learning or remembering this for the first time. So it says to multiply, and it says it's 2 minus 3x quantities squared. A lot of people try to just shower the power, which is something that you can do, but you're not allowed to do it when this is a binomial. So anytime that this has a minus sign or a plus sign in the middle, and you see that it has a squared, the way that's recommended to do it is you're going to cross out that it's a squared and go ahead and just write it a second time. So 2 minus 3x. So I wrote it a second time, and then I'm going to remember to go through and do my FOIL. You can also use the pattern that you learned in class for this if you remember what the pattern is for multiplying these out, but you can multiply it out this way too. So 2 times 2 gives me 4. 2 times negative 3x is negative 6x. And then here on the inside, I'll have another negative 6x. And then negative 3x times negative 3x gives me positive 9x squared. These two will combine together. They're not going to cancel each other out because they're not opposites. They're the same sign, so they're going to double. And then when I write my answer for this question, I'm going to write it in standard order as well. So the 9x squared will go first, then the minus 12x, and then the plus 4. Question number 10, it's a multiplication question. It's probably the longest multiplication question that you have on the page. So this one says 3x to the second minus x plus 4. And then in the second parentheses, it says x to the second plus 5x minus 1. So what makes this question longer or more difficult is a couple of things. This one has 3 and this one has 3. So I'm going to have to multiply this one through, and then this one, and then the last one. But when I'm doing the work for this question, there's just lots of places that you can make mistakes with exponents and powers and numbers, so be careful on that. You might also want to compare question 10 to question 3, 4, and 5 that we did previously. So this one had 2 parentheses, but it had a plus sign in the middle, so that's how I knew I was going to add. This one had parentheses, and this one had parentheses, but they had minus signs in the middle to start, and that's how I knew I was going to subtract. But on this one, it's not an adding question because there's no plus sign in the middle, so that's how you know you're going to multiply. We're going to have to multiply this one through, 1, 2, 3, and then we'll multiply the middle one through, 1, 2, 3, and then last but not least, we'll multiply the last one through, so that'll come through and multiply 1, 2, 3. So in your second set of work, if you have a 3 and a 3, you should have 9 things, and then a bunch of them will usually combine together. So let's go nice and slow through this one so we don't make any mistakes. Let's see, 3x to the 4th, because 3x squared times x squared would give you 3x to the 4th, plus 15x to the 3rd minus 3x squared. So when you're doing that first set of multiplication, your eyes kind of go back and forth between the problems. Anytime you're doing the distributive property, that's helpful to keep in mind. I'm done with the 3x squared, so I'm going to cover it up. And now I'm going to do the same thing with the x, and I'm going to distribute the x through. So it'll be minus x to the 3rd minus 5x squared plus x. And so I'm done multiplying this one through to each of these terms. So now I'm going to cover both of those up, and then I'm going to finish with the 4. So plus 4x squared plus 20x minus 4. So it's good to double check and make sure you have 9 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, I do. I have all 9 things. And so now for this last part, I just have to find the ones that can combine together. So I see an x to the 3rd and an x to the 3rd. And then I see an x squared and an x squared and an x squared. And then there's an x and there's an x. So this one won't have any to combine with, and this one won't have any to combine with. But other than that, there's a couple that can combine together. So 3x to the 4th is going to stay 3x to the 4th. 15x to the 3rd, take away 1x to the 3rd, is going to give me 14x to the 3rd. Negative 3x squared, take away 5x squared, is going to give me negative 8x squared. And then negative 8 plus 4 is going to give me minus 4x squared. 1x plus 20x gives me plus 21x. And then the minus 4 on the end, again, didn't have one to combine with. And so that one just drops down and stays as a part of your answer. So this is the completed answer for question 10 with everything multiplied out with one another. Your work for question number 11, it says to expand the binomial. Your work for this one might vary depending on how which teacher you have and kind of how you understand how you're going to do it best. So if the work that I do here is different, just compare it to what you learned in class. Maybe this way will help you a little bit better, but you can always just check your answer to the question. It's the same thing. If I'm combining, so if I'm doing x plus y to the 4th power, I'm going to make a table to organize my work. And so remember, the 4 columns are the table. This is your coefficient. This is your A term, which is the first part of your parentheses. This is your B term, which is whatever is the second part of your parentheses, including the sign in between. And then this is going to be the term in the expression. If you're used to not using a table and just writing it out the long way left to right, you'll just be checking that your terms match up the same as mine. So in, please have to go down one more. So for fourth power, I'm looking at the fourth row of Pascal's triangle. So in the fourth row, the coefficients are 1, 4, 6, 4, 1. That's not something that you have to memorize. Remember that you can always, on a piece of scratch paper during the test, come off to the side when you get to these questions and you can create them. So in the triangle, it starts with 1, and then down the side this way, it has all 1s. Down the side this way, it has all 1s. And then in each row, the numbers in the center that aren't the first and last one are found by adding the 2 numbers up above it. So in this second row, because this is row 0, this is row 1, this is row 2. So in this second row, the number in the middle is the number 2, and then 1, 3, 3, 1. So again, I'm adding the 1 and the 2 together to get the 3. I'm adding the 2 and the 1 together to get this 3. And then in the fourth row, it would be 1, 4, 6, 4, 1. And then in the fifth row, it would be 1, 5, 10, 10, 5, 1. So one of the things to remember is that, so if this is row 0, this is row 1, this is row 2, 3, 4, 5, the row you pick always matches up to the exponent that you're using. And then the exponent that you're using, with the exception of this first row, the exponent that you're using will always be the second number in the row. So that's how you can make sure you're picking the right one. So for x plus y to the fourth, I'm picking from the row that has 4 as the second number, just as a reminder for you. And then this continues, but that should be the only numbers that we need for the review today, and the only numbers from it that you may need for the test tomorrow. All right, so the a is the first one, and use parentheses on this because it'll matter later. So you start with whatever exponent's here, x to the fourth, x to the third, x to the second, x to the first. This one would be x to the 0, but you can just scribble it out. X to the 0 would equal 1. And then for your b term, it's my y, and remember that y's go the opposite. So they're going to finish with y to the fourth, and then y to the third, y to the second, and y to the first. And then again, this one would be y to the 0 power, but you don't need to write it down. So for the terms in my binomial expansion, I multiply these numbers across. So this is going to be x to the fourth. This one will be 4x to the third y to the first, but you don't need to write the 1. This one will be 6x squared y squared, 4xy to the third, and then last but not least, this one's just y to the fourth. So your answer to the question are these terms written out in order from left to right. And because this was a plus sign, they're all positive. If this was a minus sign, they would be flipping back and forth from positive to negative. So x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. And so that's your finished answer for that question. So on the review today, and also on the test, when you see the word expand or expand the binomial, that's your clue that this may be a way for you to do the question. It's important also to recognize that you could just multiply this out old school. So if you wanted to, x plus 2 to the third is x plus 2 times x plus 2 times x plus 2. You could always FOIL one of those pairs together and then FOIL it with the third one. But because it says to expand, I'll do the work with the expansion table. Just don't forget that you also know regular multiplication that can help you get the answer if, like on the test, you were to blank out and not sure what to do. So again, my tables are, I'm going to pick the coefficient from the appropriate row on the triangle, and then a is the first number, b is the second number, and then term is what I get when I multiply them together. So this one's x plus 2 to the third, so I'm going to look at the third row, or the one with the 3's in it. So my coefficients are going to be 1, 3, 3, 1. My a, so x to the third, x to the second, x to the first, and then this one would be x to the 0, so you just don't include it. And then for my b term, that's the second part, so it's positive 2. So this is going to be 2 to the first, and then 2 to the second, and then 2 to the third. So when I'm finding my term, I'm going to go through and I'm going to multiply these out, but just be careful because you're going to have to raise the 2 up to the appropriate power in these ones. So this is x to the third. This isn't 3x squared, it's going to be 6x squared because I have to consider the 2 that's here. This one's not going to be 3x, it's going to be 12x because 2 squared is 4, and then 4 times 3 would give me 12. And then in my last spot right here, it's not going to be just the 1 or just the 2. 2 to the third is 8, so this one's going to be 8. My answer for this question is x to the third plus 6x squared plus 12x plus 8. But again, if I had wanted to, instead of doing the question this way, I could always multiply it out just by FOILing it. If you're not sure what I'm talking about, x plus 2 to the third power would be x plus 2 times x plus 2 times x plus 2. So if you wanted to, if you panicked and if you forgot how to do it this way, you could go 1, 2, 3, 4. So that would give me x squared plus 2x plus 2x plus 4, which when I combine my like terms would give me x squared plus 4x plus 4, and then that's still times x plus 2. And then I could always finish it by foiling it out. So this one would go here and here, this one would go here and here, and this one would go here and here. So I'd be doing this, that's a little bit tight on space, and then this, and then this. So that would give me x to the third plus 2x squared, and then I'd be done with this one. And then it would give me plus 4x squared plus 8x, and then I'd be done with this one. And then plus 4x plus 8. These two would combine together, these two would combine together. And so what you can compare is your answer to this question, x to the third plus 6x squared plus 12x plus 8. So if you did it out this way, you would get the same answer that you got out here. So notice that these two answers would be the same thing. Obviously, if it was to the 5th power or to the 6th power, then the binomial expansion method would be better. But at the end of the day, we're just testing to see if you can multiply this out. So you're welcome to do it that way and still get the correct answer to the question. All right, for question number 13, this is my last expansion. So this one says that I'm going to expand, and then I'm given a binomial. So this one says 3x minus 1, and it's raised up to the 4th power. And so again, I'll do it this way. When there's a number in front of the 3 or any coefficient in front of a variable, you just want to make sure that you go a little bit more slowly through this process. So when I'm doing the work for this one, because this one has the 3 in front of the x, I'm just going to be extra careful. The number's 4, so I go 0, 1, 2, 3, 4. So I go to the row in the table that has the 4s in it. So 1, 4, 6, 4, 1. Those are going to be my coefficients. My a term is the first part. So this is going to be 3x to the 4th. Don't forget the parentheses here because they do matter. And then 3x to the 3rd. And then 3x squared. And then 3x. And then this would be 3x to the 0 power. But again, you can just omit it. And then for your b, you're going to omit the first one. And then remember, your b's either go down in order up or they go up in order down. So it's going to be -1. Don't forget the negative to the first, -1 to the second, -1 to the third, and then the last one would be -1 to the 4th. So when you're doing the workout for this one, you're going to need to cube the 3, or it's not cube, you're going to need to raise the 3 up to the exponent and whatever that number is up to the exponent. And I'm not too proud to not use a calculator. So 3x to the 4th is going to turn into 3 to the 4th, x to the 4th, and 3 to the 4th is 81. So this term is going to be 81 x to the 4th. For my next one, 3, oh, I put that parentheses in the wrong spot. Here. That's supposed to go here. So 3 to the 3rd is 27, but then 27 times 4 gives me 108. Before I write the 108, notice that I'm also going to be multiplying the 108 by -1. So this is actually going to be -108 x to the 3rd. So one more time on that one. 3 to the 3rd was 27. 27 times 4 was 108. But then I'm multiplying the 108 by a -1. And so that's how I'm getting the -108 that's right here. On the next one, 3 squared is 9. 9 times 6 is 54. And then -1 squared is +1. So this one is going to stay positive. 3 to the 1st is 3. 3 times 4 is 12. But -1 to the 3rd power, -1 times -1 times -1 is -1. So this is going to be -12x. And then I'll finish my last term, -1 to the 4th power is +1. So my last term is just a 1. So again, written out from left to right, 81x to the 4th minus 108x to the 3rd. So you just write down the terms that you get from the table in order. And so this would be your expanded expression from expanding that binomial. I won't do it for this problem because the video is already long, but notice that you could do this out the same way as this one, except you would have 4 of these. So it would definitely take longer for most people to do it this way. But if you blanked on this, there is a way that you can answer the question without remembering this process. So just keep that in mind. All right, factoring. Question number 14 gives us an expression and it asks us to factor it. So on this one, I'm going to be factoring negative 3x squared plus 12x to the third. And so the directions on this question do say to factor. I didn't write that part down. When I'm doing the factoring on this one, notice that there's 2 terms, so it's a binomial, and they have something in common with each other. Your teacher might have called this hockey stick, or your teacher might have called it factoring by GCF. But what I'm going to do is I'm going to draw this on the problem, and then I'm going to divide out whatever it is that they have in common with each other. So both of these can divide by a 3, and then both of them also have 2 x's that they can give me as an answer to the question. So if I can take out a 3 and if I can take out 2 x's, sometimes the common way of us doing this is writing it over here. So negative 3x squared is the thing that I can divide out from both of them. If I divide out negative 3x squared from negative 3x squared, I would have a 1 left over. And if I divide out negative 3x squared from positive 12x cubed, 12 divided by negative 3 is negative 4. And then, let's see, x to the third, if I take out 2 of the x's or divide that by 2 of the x's, I would have 1x left over. And so for this one in factored form, my answer would be negative 3x squared, parentheses 1 minus 4x. With factoring, there's a couple different rules that you follow. So you usually don't write your answer in standard order here. You usually keep it in whatever order would get you this back. So that's why I didn't flip these 2 around. And then the last thing is, if the leading coefficient in the order that it's written is negative, the rule usually says that you take out a negative. So that's why I took out a negative 3x squared instead of a positive 3x squared. Question number 15. The directions to this question also say factor. Here, I'll write it on this one. And so for this one, I'm factoring x to the second plus x minus 6. This is a trinomial. There's nothing between the 3 of these terms that they have in common. And so when I factor this trinomial, there's nothing I can start by taking out with either the hockey stick method or the GCF method. So when I factor this one, I'm just going to be doing a t-chart and then writing my answer. So on this one, x times x would give me back x squared. And then I'm looking for the numbers that would times to give me 6, negative 6, that are 1 apart from each other. So sometimes it helps students to make a list. It's either going to be a 6 and a 1, or it's going to be a 2 and a 3. And I want it to be a positive one, so that's how I know that it's going to be positive 3 and negative 2. So again, in factored form, this one's going to be x plus 3 times x minus 2. If that x that was in the middle was the number negative 1, then I would want the negative on the 3 instead of the 2. And if the x that was in the middle was like negative 5 or positive 5, then I would use 6 and 1 as my numbers instead of 3 and 2. So it does matter which numbers you pick, because there's only going to be one way of factoring it that works for each question. Question 16 also says factor, and so on this one, I'm factoring x to the second plus 2x minus 15. And so again, I'll use the same pattern. There's nothing to hockey stick out. Since there's nothing to hockey stick out, I just get right to t-charting. X times x gives me back x to the second. And then for 15, I can either use 15 and 1, or I can use 3 and 5. I want the numbers to times to give me 15, but I want them to subtract to give me positive 2. And so I'm going to use the 5 and the 3 to get 2, because the 15 and the 1 couldn't give me 2. Because the 2 is positive, I want the 5 to be positive, and I want the 3 to be negative. So in factored form, this one would be x plus 5 times x minus 3. Just a quick note, remember that your answer to the question, multiplication can be flip-flopped and you get the same answer. So you could write these in the other order, you could write these in the other order, and your answer to the question would still be correct. So it doesn't matter which term you put first, just make sure that the positive and the negative are on the correct number. 17 also asks us to factor. And this one, it's x to the second minus 14x plus 49. This one is one of the special pattern problems, but you don't have to know that to factor it correctly. You just follow the pattern with the t-chart. So x times x would give you back x to the second. And then you're looking for different numbers that times to give you 49. But you want them to add up to give you negative 14. So because the two things are timesing to give you a positive, but they're adding up to give you a negative, that's how you know that you're going to want both of them to be negative. And then out of these two options, the only ones that add to give you 14 are 7 and 7. When you write your answer to this question, you can write it out this way, or because it's a perfect square binomial, you can also you can write it out with the squared term instead. You can only do that though when they match exactly, so be careful about that. On question 18, the directions say to factor. And this one is 2x squared plus 3x minus 2. So just a little note before we start on this one. Whenever it has a number out front, you want to go a little bit more slowly because it means that it might, it's going to take an extra second to figure out your t-chart since there's different ways to get 2 and 2. Let me show you what I mean. There's nothing to hockey stick out, so you don't hockey stick anything out. To get a 2, you can only use 2 and 1, and to get a 2, you can only use 2 and 1. But because this one is going to have a 2 in front of one of the x's, 2x times x gives me back 2x squared, I have to be careful on this side about where I put the 2 and where I put the 1. I'm trying to have the numbers subtract to give me 3, positive 3. And so in order to get a 3 out of a 2 and a 1, and to have the 2 over here be negative, I'm going to have to put the 2 diagonal from this 2 and then put the 1 up here. And then the negative sign is going to go on the 1, not on the 2. This would give me positive 4x. This would give me negative 1x. And 4 take away 1 is how I would get the positive 3. If you put these numbers backwards, or if you put the negative on the 2 instead of the 1, it wouldn't give you back this exactly if you FOILed it out. And that's actually another good point to make here, is that any of these questions, if you want to make sure that you got them right, like if I wanted to be 100% sure that my answer to this question was 2x minus 1 and x plus 2, I could always go back and refoil this out to check and make sure that I get the same original answer back. And so you're welcome to do that as many times as you want to on the test. Let's see, question number 19 also says factor. And so on this one, I'm factoring 4x squared minus 25. Again, this is one of those special pattern problems that you can notice, but if you want to, you can still just approach it with the same t-chart. You have an x squared term, so it's either going to be 4 and 1 or it's going to be 2 and 2. You have a 25, so it's either going to be 25 and 1 or it could be 5 and 5. But notice that there's no x term in the middle, so that means that when you do the crisscross multiplication, you're trying to have these be opposites of each other. And so if you remember from the pattern said if this number had a square root, a perfect square, so it does, which is 2, and if this number had a perfect square, which it does, it's 5, then that might be where you want to start. So 2x and 2x, and then 5 and 5, but that wouldn't give me negative 25. So I would need one of these to be opposite the other one. And then notice what happens when I do my crisscross. This way gives me negative 10x, this way gives me positive 10x, and so they would cancel out, and that's how I get the 0 in the bottom. When you write your answer to this question, you can't write it with the squared because they don't match exactly. So you just have to write it out. So one of them will be positive and one of them will be negative. And this happens, it's called the difference of two squares, but this happens anytime the middle term cancels out. So question number 20 is another factoring problem. Again, on this one, there's nothing that you can divide out to start. So question 20 says to factor, and then it's having me factor 12x to the second plus 17x minus 5. So there's nothing that I can GCF out of any of these. And so because there's nothing that I can take out, it just means that I'm going to have to be patient when I do my t-chart because the numbers are a little bit bigger. 5 is only 5 and 1, so that's nice. But 12 is 12 and 1. It could also be 6 and 2. It could also be 4 and 3. So it could be any of those numbers together. Most of the time when people factor, they use a pencil because there's a lot of erasing that you might potentially have to do. I'm trying to get 17 when I'm subtracting things. So I know I have to use the 5 and the 1. I'm going to start here on the bottom. So 4 and 5 would be 20. No, 3 and 5 would be 15. 1 and 4 would be 4, but 15 and 4 wouldn't give me 17. I'm subtracting them to get 17, remember. 5 and 4 is 20. 3 and 1 is 3, and then 20 take away 3 would give me 17. So I'm going to use 4x and 3x. And then on this one, I want the 5 to go with the 4 to get 20, so I'm going to put them in that order. This way would give me 20. This way would give me 3. I'm trying to have them get negative 5, but I want the 17 to be positive, and so that's how the 1's going to go on the negative will go on the 1 instead of going on the 5. So this would be 4x minus 1 times 3x plus 5. A problem like this that had kind of complicated numbers is usually a good problem to go back through and check. So let's do a check on this one just so that you can see what I'm talking about. So if you have 4x minus 1 times 3x plus 5, and if you wanted to check and make sure that this was correct, I would FOIL it and then combine like terms to make sure that I got back what I started with. So 12x squared plus 20x minus 3x minus 5. So I did first, outside, inside, last. And then I would combine my like terms here, and so I would get 12x squared plus 17x minus 5. And since this answer matches with this answer, that's how you know that you did the problem right and your answer to the question is correct. So in question 21, it also asks me to factor. Question 21 says that I'm going to factor this expression. (3x to the third minus 3x to the second minus 6x. So one of the things that you might notice right away about this is that it's to the third power, and so that means that there's something about it that I need to change before I can do my work for the question. So anytime you're factoring something, you always want to see if there's a greatest common factor or something that you can hockey stick out first. So from these three terms, they all divide by 3, and they all divide by x as well. So I can factor out a 3x from all of them. That'll leave me with x to the second, because 3 divided by 3 gives me 1, and then x to the third divided by x to the first would leave me with x to the second, minus x, because this divided by this would leave me with just x, and then minus 2. So the expression that I have left over could continue to factor more, and this one does factor more. So you would want to try to t-chart it. X times x gives you back x to the second. And then over here, I'm trying to look for numbers that times to give me 2, so it's just going to be 2 and 1. But they have to add up to give me negative 1, so I'll put the negative on the 2 and the positive on the 1. You want to be careful with this because when you write your answer to this question, don't forget the 3x that you took out front. A lot of people forget that when they write their answer to the question. So the 3x traditionally would go first, but then the x minus 2 and the x plus 1 could go in either order because multiplication can flip-flop. It's commutative, so you can put it in either order. Let's see, for question 22 I'm still factoring, but this one's different. And I know it's different right away because when I write down the question from the very get-go, I see that it has 4 terms. So this one's going to have me factor x to the third minus 2x to the second plus 5x minus 10. So on this one, I can't t-chart it. I know I automatically can't t-chart it because it has 4 pieces, and you can only do a t-chart when there's 3 terms sometimes, and then you can sometimes do it when there's 2 terms. But for this one, it's not going to work with the t-chart. So anytime we factor with 4 terms, that's going to be factoring by grouping. So I'll hockey stick the first 2, and I'll hockey stick the second 2, or factor by GCF. I can take an x squared out of both of these, so I would have x minus 2 left over, and then I can take a 5 out of both of these, and so I would have x minus 2 left over. Anytime this answer matches, it means that you can factor it by grouping, but remember how you write your answer. Just because you see this one that matches twice, you don't write it with a squared. I'm going to write the x squared plus 5, and so that's part of my answer. And then whatever was the factor that matched, the factor that it had in common, I just write that once. And so in factored form, question 22 would be x squared plus 5, and then the second parentheses would be x minus 2. But again, this could get written in the other order and it would still be correct. Question 23 also has 4 parts, and so that's your clue that for question 23 you're also going to be factoring by grouping. So it's x to the third plus 4x to the second minus 9x minus 36. That's probably one of the hardest parts about all of this factoring, is that by itself, the factoring you can kind of get the hang of, but it's hard to remember in the context of doing other problems how you're supposed to get each answer to the question. So you want to try to look for patterns. So one of the patterns that you can see with this is that anytime there's 4 pieces, it's usually going to be factoring by grouping. I can take an x squared out of these two, and that'll leave me over with x plus 4. And then I can take a negative 9 out of these two, and that'll leave me over with x plus 4. This wouldn't work if I didn't take the negative out of these two, because it would be left over with negative x minus 4, and then these two terms wouldn't match. And remember, part of the thing with grouping is that these leftover pieces have to match with each other. So I can write my answer so far. So I write the top part together, the part that I GCF'd or hockey sticked out of both of them, and then the thing that matches I write once. But if you look at the back of your review, this isn't going to be the answer. And that's because this can keep factoring. You can either factor it with a t-chart, or you can factor it by recognizing that it's one of the special pattern ones. This one couldn't factor because it was a plus sign, but also because 5 is not a perfect square. But this one has a minus sign. I can take the square root of this one, and I can also take the square root of this one. And so if I t-charted that, x times x gives me back x squared. Positive 3 times negative 3 gives me back negative 9. And when I do my crisscross multiplication, I would get that 0 that's here in the middle. That's why it's missing that third term. So my final answer for this question actually has 3 parts to it. It would be x plus 3, x minus 3, and x plus 4. And again, those could be written in any order. This is the factored completely format. So this isn't wrong, it's just not finished. This is the version of it that's finished. On question 24, you're asked to factor as well, but this factoring is again different than the factoring that was on the previous page. So for question 24, I'm going to factor this difference of cubes expression. So a couple things about it. First of all, I notice that the first one is to the third power. And then I can take the cube root of 125 because 5 times 5 times 5 gives me back 125. Sometimes they'll have a plus sign in the middle, and sometimes they'll have a minus sign in the middle. And so it just depends on which one it has for the pattern for your answer. This problem right here, when I do the workout for it, it's going to follow the special pattern that's in my notes. So make sure that you memorize those formulas so that you can go through and do them. Your teacher might not have done the work exactly like this, but in the pattern, your first term, your A term is going to be the cube root of whatever the first part is, and then your B is going to be the cube root of whatever this part is. If it's negative, don't worry about putting the minus sign right here. You don't need to include the minus here because we're going to accommodate for it when we plug it into the formula. Some people like to plug it into the formula letter by letter, and some people like to follow the pattern that you can follow when you're doing these. So the pattern says, when you're writing your answer to this question, it says that you're going to do A minus B, so this first sign always matches what this part is right here. So that's where the x minus 5 comes from. And then the pattern says you square the first one. It's always the opposite of whatever this sign was. So if this was a minus, this was a minus, so that one would be a plus. And then you multiply these two factors together, so that gives you 5x. The last sign is always positive. And then to find the last part, you would square this part, so it would be 25. And so this is the answer to your question. So that would be the factored form of that difference of cubes. But remember, it's following the pattern for difference of cubes. It's following the pattern that looks like this. And so your teacher might have given you these formulas to memorize. Just make sure you're careful because those won't be given to you on the test. But you can follow what we said here. So this is the same sign as the first one was over here. I square the first one. It's the opposite sign that it was here. I multiply together the factors to get this part. This is always positive. And then for this part, I square whatever this one was. So it follows that same pattern as you go on the way through. So if you like that, you can use that pattern. Otherwise, you can memorize, and then plug it into the formula. For question 25, the directions to the question also say factor. And so you can see by the way that it's set up, so it's 27x to the third minus 8. So it's following that same pattern as the one before. It's not just because it has two pieces. It's because this one has a third power. 3 times 3 times 3 gives you back 27, and then 2 times 2 times 2 gives you back 8. So for this one, my a term is going to be 3x, and my b term is going to be the number 2. Remember, when you pick a and b, you don't have to worry about whether it's positive or negative. You'll accommodate for that when you plug it into the formula. So for this one, if I'm going to go ahead and follow the pattern says it's the sign in the first one matches. So this one would be 3x minus 2 in the first parentheses. And then if you follow the pattern for the second part, it says you square the first one. So I'm going to square my a. So that's where I get the 9 and the x squared from. The second sign is always the opposite. So this one will be a plus sign. To get the next one, I multiply these two together. My last sign is always positive. And then for my last spot, I'm going to do my b term, whatever my b term is, squared. And so again, you can follow sort of talking yourself through the pattern, or you can memorize this formula. It's the same one as up above, but I'll write it again. And so this gives you the pattern for that, for 25 and for 24. It's the same pattern. On question 26, the directions to the question, this is our last factoring example. X to the third plus 64 y to the third. I know it's following the same pattern, even though this one has a plus sign and these ones had minus signs. I still know that it's following the same pattern because I can do the cube root of this. So x is the cube root of x to the third. And then I can also do the cube root of this because 4 times 4 times 4 would give me back 64. And then y times y times y would give me back y to the third. So on this one, my a will be x. That'll be the first part. And then my b is going to be 4y because it's the cube root of this and the cube root of this. The only thing that's different about 26 is that it's a plus sign in the middle instead of a minus sign in the middle. So when I do my pattern, it's going to be a little bit different. The first one says I just add them up, so it's this one plus this one. And then in the second set of parentheses, the pattern's the same, so you do the first one squared, but then this is the opposite sign. You multiply the two of them together, so that's this one times this one goes here. The last sign is always a positive sign. And then to get my final term in the expression, I'm going to square this one, so it's going to be 16y to the second power. And so this would be that sum of cubes factored in factored form. You can remember the pattern, or you can memorize the formula. Just make sure that you actually memorize it. And so that's what the pattern would say for that one. So this thing that I'm writing up above it isn't part of the answer. The thing in the box is the answer to each question. For questions 27 and 28, I want to remind you that some people prefer to do this on graph paper because it helps them line up their work for their question. So for 27 and 28, if you would prefer to do it on graph paper, go on ahead and grab out a piece and then you can line up your work in your boxes. Otherwise, we're going to do the work. And so the directions for these ones say to use long division to divide. And so with long division, you want to make sure that you're being careful about lining up your work. So on this one, on your green paper, you can see the way that it's set up. You're going to be dividing something with 4 terms by something with 2 terms. So remember from before, the thing that goes second, or the thing that was second typed out, that goes on the outside. And then the first part goes on the inside. So x to the third minus x to the second minus 5x plus 2. And I kind of spread it out a little bit when I write it, just because I know I'm going to be going through and doing the division steps. Your teacher may have given you different ways of doing this, so just kind of follow along. It's the same general idea. They might have just used different words. The algorithm for division says you want to ask yourself, what's this first part divided by this first part? So if you did x to the third divided by x, you'd be asking yourself, what do you times an x by to get back x to the third? And that would be x to the second power. So x to the second power would go here. And then it's sort of like the distributive property when you do this part. So x to the second times x would give me x to the third. Remember, you always want this one to match exactly to start. And then x to the second times 2 would be plus 2x squared. And I lined that up right underneath this other one. Addition, or rather subtraction, is the same thing as adding the opposite. So on this one, when I add the opposite, I'm going to change this one to a negative, and I'm also going to change this one to a negative. When you combine like terms, you're going to add vertically. These two will always cancel out if you did it right. And so then you just have this other part to finish with right here. So negative x squared take away 2x squared is going to give me negative 3x squared. And then I know I'm ready for the next step in the problem when I drop down my 5x and I get ready for the next part. So that's one whole cycle through the process, and so now you're going to do it again. So to get an x to be a negative 3x squared, I'm just asking myself, what do I multiply this by to turn it into this? Or you could conversely think about it like division. What's this divided by that? And so that would be negative 3. So negative 3 times x, or sorry, not a negative 3, negative 3x, because you would need 2 x's to get back this x right here. So when I multiply negative 3x times x, that gives me negative 3x to the second. And when I multiply back negative 3x times 2, that gives me minus 6x. But then remember, the pattern says that subtraction is the same thing as adding the opposite. So you're going to add the opposite, add the opposite. If you do it right, these two will be opposites of each other, so they'll cancel out. And so you're just adding up this part. So negative 5x plus 6x would give me 1x. And then my plus 2 would drop down. And then what do you times an x by to turn it into an x? That'd be 1. I do my distributive property. So 1 times x is x, 1 times 2 is 2. And then subtraction is the same thing as adding the opposite. And so I finish with 0. When you finish this question with 0, that means that there's no remainder. But make sure when you're careful the way that you write your answer, this piece up here at the top is your answer to the question. So for this problem, your answer would be x to the second minus 3x plus 1. And so it's not the 0 that's left over at the bottom. That's not your answer to the question. It's whatever this piece is at the top. So this problem had no remainder, but the last problem in the work for today will have a remainder. Just grab a piece of paper. All right, last but not least, question 28. You don't know ahead of time that it's going to have a remainder. I mean, you can look at the back of your review, but this one will end up with a remainder. And so we're going to use long division to divide. And so on this one, I'm dividing x minus 5 into 2x to the third minus 7x squared minus 11x minus 17. Notice that on this one, on neither of these problems did you have to leave the space. So if it was missing one in our notes, we put a 0 in front of a number and left a spot for it doing the division. Notice that on none of these did you have to do that. So these ones are just, they're descending one at a time to get from each number to the next. So to make an x turn into a 2x to the third, I would have to multiply it by a 2 and an x squared. And then I'll do this step. That's going to give me 2x to the third minus 10x squared. And then the pattern says that subtraction is the same thing as adding the opposite, so I'll change the signs on both of those. Negative 7x squared plus 10x squared gives me 3x squared. Remember, I kind of ignored it, but these ones will always be opposites if you did it right, so they'll just go away. And then I'll drop down my minus 11x, and then I'll repeat the process again. X would need to be multiplied by 3x to turn into 3x squared. But then I'll also do this one times this one, so minus 15x. And then subtraction is the same thing as adding the opposite. I'll drop down my 17. And then I actually know that this is going to be the last step in the problem, because when I drop down my 17, there's not going to be any other numbers to drop down. So if this works out perfectly, it's great. Otherwise, I'll just have a remainder for my problem. X times 4 would give me 4x. And then subtraction is the same thing as adding the opposite. And so on this problem, I'm left over with a 3. So my remainder for this question would be 3. But remember the way that you write your answer. Your remainder is always going to be plus. And then if it's positive, it'll be a positive number in the top. If it's negative, it'll be a negative number in the top. And then this x minus 5 would go in the bottom. And this is the answer to my question. So for performing this division, I get 2x to the second plus 3x plus 4 plus 3 over x minus 5. And that's your completed answer to this question for once the division is performed.